And welcome everybody to our Fields and Features segment. In this segment, we'll be talking about things like solar flares and the magnetic environment around Earth, which is what we're looking at right now. You're looking at Earth's magnetic moment from space, as modeled by the Space Weather Modeling Framework. It's showing you the scale of magnetohydrodynamic pressure. The units there is nanopascals, and we may see a period of geomagnetic unrest in the process of returning here, as we're seeing the BZ component, which is the vertical component of the magnetic field measured at Lagrange point 1, shift into negative territory. So all we need is a little stronger shift of that BZ in the negative to produce enough currents to produce geomagnetic unrest. That's the last 4 hours magnetohydrodynamic pressure. Here are ground magnetic perturbations, changes to Earth's B field, known as geospace delta B from the ground level. The scale here, nanotesla, that's magnetic flux density. Because here we're looking at the field, not the behavior of the plasma in space. So like the last frame, that's 4 hours of data. And let's blast through a lot more as we've got coronal mass ejections headed toward Earth. So next is the heliospheric current sheet. There is a North Pole current sheet speeding this way, as you can see there. If everything remains the same, we can expect to be in a North Pole current sheet tomorrow. So if you look at the last frame there, you can see this North Pole current sheet speeded toward Earth. The sun split evenly right around the Earth line here between north and south polarity for the solar plasma. Next, we'll take a look at the GOES magnetometers, and we're seeing low readings here. There is a lot of plasma in between the sun and the Earth at the moment, as there is a continuing coronal hole wind stream. Let's take a look at some more data. Here's the line of sight view. It's basically the same as the top view ecliptic plane field plot, just from Earth's perspective instead of as if viewing the sun from above. Looking across the ecliptic plane, you can see that North Pole green colored current sheet headed this way. Here's the line of sight coronal hole plot. You can see the sun's B field here in blue. And you can see some North Pole oriented coronal holes rotating through here. So let's just stop this at the last frame. There you go. You can see some green colored coronal holes there. Those are North Pole oriented coronal holes as solar cycle 25 progresses and the solar polar fields migrate to the opposite pole. So here's a great view in 193 angstroms. You can see a bunch of plasma kind of reorganizing itself here, covering up a coronal hole. There were also some significant solar flares. We'll cover that in a moment. First, sunspots. So there's a great view of some coronal holes for you in 193 angstroms from the SDO. Next, sunspots. And we've got 3 major groups here. For some reason, this imagery here isn't animated, so we'll just ignore that. Likelihood of solar flares is still there, especially from sunspot 2941. We've seen flares actually coming from behind the limb. So there's 2941. It's mostly stable over the past 24. And this is 2946. That's the second largest group. There is another significant group down here in the south. This group here. It is beta class as well. It's not really worth doing a close-up here in 1700 angstroms. There it is down there. That's capable of producing some flares as well. So yeah, that's kind of the state of affairs. You could say 3 beta class sunspot groups. But the only major sunspot really is 2941. 2946 is significant, I'll just say that, and not get any more into the weeds. So here you can see we saw 3 major flares over the past 24. One M class, one slightly smaller. A high C class level, I think that was a 9.1. Then another rather large C class flare. So we've brought up the 171 and 131 angstroms wavelengths here. Those are both ionized iron species. The ultraviolet emissions from superheated iron gas. And we haven't seen any relativistic particles from any of those solar flares yet, or associated with any of those solar flares yet. No relativistic particles showing up yet. So there is a coronal mass ejection headed this way. We'll get to it here in a moment. First, we'll look at the real-time solar wind, and you can see the BZ component here, which is the top frame. The BZ component is the vertical aspect of the total field. So the BT is the total field, and the BZ is the extent to which it's coming from either the north or the south, essentially. So when you see a negative BZ, that is more apt to induce currents here on Earth because of the interaction between the magnetic fields. So it looks like it's headed back to the zero line here. So the likelihood of more geomagnetic unrest here is diminishing as time goes on. We see a slight reduction here in the solar wind speed over the past 24 hours. Current conditions are still over 500 kilometers per second at 514. Solar wind density 7.5 or so. We may be seeing the end of the coronal hole stream happening right here as we see the plasma temperature dropping off just in the past few minutes while we record the video. So the KP index is at 3. We're not really expecting that to go back to 4 at the moment. And since we like to do forecasts, here's an easier forecast than the ones that require thought and understanding of physics. It's a forecast of the heavenly bodies in the solar system. Let's advance this 1 week. And there's where things will be. In a week, we'll have a crescent waning moon by then as a full moon approaches. So here's what's going on above my head in Lehigh Valley. I use in-the-sky.org. The yellow line is the ecliptic. The blue line is the galactic plane. If you're up before dawn, you may see a planetary pileup featuring Mars, Venus, Mercury, and Saturn all rising ahead of the sun. And let's take a look at the coronal mass ejection. So there are some coronal mass ejections headed Earth's way, at least one likely to strike Earth, almost 100% likelihood. So let's take a look at the view from stereo A and from the LASCO C3. So there was a huge piece of missing data here. That's the first thing I want to cover. There was a big chunk of missing data, about 8 hours worth. But when we use the LASCO C3, we can get an idea of what's going on, and it looks like there's some ejecta headed toward Earth. So the LASCO C3 is located at Lagrange point 1 for you new viewers out there. The LASCO C3 is right here in between the Earth and the Sun, about 1 million miles toward the Sun from the Earth. And when you see a halo, you can expect some fireworks in the form of aurora, possibly even power outages and things like that, induction into pipelines and railroads and so on. And we'll just animate this. So there are the past day or so of imagery from the Lagrange point 5 here, stereo A. And once again, for you new viewers out there, Earth would be off in this direction from the perspective of stereo A. And it would be behind you from the perspective of the SOHO LASCO C3 coronagraph. So yeah, we've got some additional modeling to do here. Again, expecting some coronal mass ejections to strike Earth. Thanks for tuning in. We've got one more video to come out with today. It's our bonus features segment. Make sure you check that out if you haven't. Thanks for tuning in. And may that solar wind be at your back.